All right, this is the second video for Friday's assignment where we are writing our own rules for exponents. So if you were looking for groupings 3 and 4, that is the previous video. This one is going to be about groupings 5 and 6. So here we go. When I look at this, I notice, well, this top one actually was a little confusing to me at first, to be quite honest, but I'm noticing that these are the same base, different bases and the same exponents. Let me say that again. Same exponents, 11 and 11, different bases. And really, that's what they're doing here as well. And I'll show that example in a moment. So the rule is when you are multiplying with the same exponent, you multiply the bases and keep the exponent. We multiply this as 2 times 5 to get 10 and keep the exponent as 11. Let me show it with G up here because I think this one's just a little bit more complicated. And so I want to show it for you. If my pen will cooperate. Okay, so multiplication can be written in any order, right? That's something we've known for a while about multiplication, that we can switch the order. 2 to the 5th times 5 to the 4th is the same as 5 to the 4th times 2 to the 5th. We can switch the order all that we want in multiplication, and that's really important in what we're about to do. So let's start by writing this in expanded form. 5 to the power of 4, that's 1, 2, 3, 4 of these that we're multiplying together. I apologize, writing with a mouse is kind of tricky. All right. And then 5 twos. So we've got 1, 2, 3, 4, 5. And they're all should have little dots in between here that we're multiplying them together. All right. So all I've done is write this in expanded form. And then I said we could mix up the order all that we wanted to. So we're trying to prove that we can get 10 for our base to the power of 4. We want 4 tens. Well, hey, I know that 5 times 2 is 10. So let's see how many times I can do that. This 5 times 2 gives me 10. This 5 times 2 gives me 10. And I can do that 2 more times. So all these 5 times 2's give me 10. I'm left though with one more 2 all by itself. So we'll just put it at the end here as times 2. And I've got to go back, put little dots here to make sure you guys know that's multiplication. All right, so each of these 5 times 2's gave me 10. Well, hey, how do I rewrite that as an exponent? Remember, I want to prove that it can be written this way. Do you see it? There's how many tens? 1, 2, 3, 4. So we can write that as 10 to the power of 4. And then we still have to leave this little times 2 at the end. So this is showing how if you write it out in expanded form, that you can multiply these little groupings of numbers together. In this case, 5 times 2. In this case, it would be 2 times 5 is getting us these tens. And we can do that over here 11 times. So you can write that one out if you want to as your example and just to prove to yourself that it would work. All right, you can pause here if you need to see any of that again or to write it down on your own Jamboard. Grouping 6. I notice this is something to the power of 0 and they're saying it equals 1. The rule is anything to the power of 0 has a value of 1, a value of just the number 1. But let's look at why that's true. Okay, we're going to use some of our other rules to prove it. So we also should think like, how do we normally get zeros and how do we normally get ones that we know from math, from all the years of math that we've had? And one way I know to get the number 1 that we've been doing a lot in math this year is when you have any number over itself, you get 1. Okay, so let me put an exponent on here, and it actually doesn't matter which exponent I put as long as I'm putting the same one. So 10 to the power of 1 divided by 10 to the power of 1, well, that would equal 1 because anything divided by itself equals 1. Another thing we learned though is we learned that if you're doing division with exponents and they have the same base, that you can keep that base of 10 and subtract the exponents. 1, uh-oh, I just messed up. Let me get a little eraser there. I want to write 1 minus 1 up here. So when we are doing division with exponents, we can keep the base the same and subtract the exponents, right? That's also true. So this can be rewritten as 10 to the power of 1 minus 1. Well, what is 1 minus 1? It's 0. So here I've proved it by showing that any number over itself, any number divided by itself is 1. That's something we've known for a long time. And I'm also showing that we can rewrite this as 10 to the power of 1 minus 1. And 1 minus 1 is 0. Oh, that didn't blow your mind. I don't know what will, but it is kind of a big concept. It's a bit crazy. All right. So you can pause the video, fill in your own Jamboard, and good luck with this, you guys.